Hello everyone, welcome to the lecture class of Advanced Construction Technique. In this class, we'll be discussing a new topic from Unit 2, Superstructure Construction. Okay, the new topic is vacuum dewatering of concrete. Okay, the first question that comes to your mind is, what is vacuum? Okay, so vacuum is a empty space or devoid that is created by the air. Okay, so dewatering. Okay, the second term is dewatering is nothing but the removal of water. So, okay, so where do you remove water? We are removing water from concrete. Okay, we know the concrete is combination of 4 different materials, right? What are they? It is made up of cement, fine aggregate, coarse aggregate, and water. So water plays a major role in the making of concrete. Okay, so we are using concrete as a material in flooring. Okay, so in making concrete flooring, we are applying vacuum to remove excess of water that is present in concrete. So this is a basic introduction about vacuum dewatering of concrete floor. So in general, we are removing excess of water from your concrete with the help of vacuum. Okay. Okay. So this is an introduction of part is given here. Okay, we know concrete is most versatile. Okay, why it is versatile? Because you can achieve any shape, size, and concrete can be used in any part of the application. Okay, so it is the most versatile material, and the lifetime of concrete is more when compared to other flooring material. But still, concrete has some deficiency is also been counteracted. Since concrete is a heterogeneous material, it is made up of 4 different materials. It is not made up of single material. It is made up of 4 different material. Certain deficiency is also counteract. Okay, to overcome certain deficiency of concrete flooring, a new system is being developed, that is vacuum dewatering flow. Okay, so this dewatering process is more important to maintain the durability of the concrete. Okay, first question that comes to your mind is, why do we add water to concrete? Okay, why do we add water to the concrete? First reason would be, it brings the all material together. It helps the material to bind together so that it improves the workability. So in 4th point, you can see for workable and easy pourable. Okay, so you make the concrete to be workable. Okay, so the workable is nothing but you will be easily handle it. Okay, so that you can easily mix it well, you can easily handle it. Okay, then purpose of adding water is next is your hydration process. Okay, so how long the hydration, that is heat of hydration takes place. Okay, but only by the addition of water only the heat of hydration takes place. Only if the heat of hydration takes place, you will achieve the strength, that is your desired strength will be achieved here. Okay, but if we add excess of water to increase both workability and the heat of hydration process, it results in reduction in strength. That is the very first point given. Okay, it results in the reduction in the strength. To maintain that, to maintain optimum water content, this system helps in removing the excess water. Okay, so by removal of excess water, we'll be able to maintain ideal water cement ratio. Okay. So this system, that is a vacuum dewatered concrete floor, will help you to maintain all the properties of concrete without compromising the property. Okay. Next slide is what type of grade of concrete is used. Okay, we know several concrete grades are been available. Right, we know M10, M15, M20, M25R, and etc. are more available. So what does 20 stands for? It's nothing but your compressive strength of concrete at 28 days width. Okay, so what is the nominal mix of M20? It is 1:1.5:3. For M25, it is 1:1:2. Okay, so these two types of grades are used in vacuum dewater floor. So this concrete grades are used here. Okay, so with the help of vacuum pump in a controlled manner, we will be able to remove the excess water. After removing the excess water, we will be using the traveling technique. That is power traveled. Okay, so traveling is nothing but you're finishing the concrete surface. To achieve a smooth finish and dense surface, we have to travel it. In technical term, for finishing the surface of concrete, we call it as traveling. Okay, then question comes to your mind. What is the fundamental need of deriving at this type of system? One, it gives you a value of money. Second one, you can able to achieve high accuracy flow level. Okay, and it also improve the wear resistance. Is it clear? And is the need for, as I said in the earlier slide, we have discussed the mixing of water. Okay, it helps in hydration process. The first point is hydration, and second is the lubrication. So it helps in lubrication, acts as a lubrication, so that it will be able to mix well, place well, and consolidate. Okay, well, this is the what are the advantage if you add excess water, but if you add excess of the water, it results in some of the disadvantages also. Okay, so it results in plastic shrinkage cracking. Okay, so an excessive bleeding of concrete also takes place, as I said. So bleeding is nothing but your cement particle moves upward, whereas the heavier material like coarse aggregate will settle down at bottom. So by both the process, your desired strength will go down. Okay, and the quality, durability of the concrete will also not be achieved as desired. So this slide shows you about what are the instruments that are used in vacuum dewater flow. So first one is vacuum dewatering pump. Okay, so this system is pump. Okay, that helps you to reduce the water content up to 15 to 25%. So what does it pump does means it remove all the air bubbles that is entrapped in the concrete laying. Okay, it removes the excess air bubbles. After removing the air bubble, we finish the surface. Okay, that finishing of surface is done by floater machine. Okay, that is floater machine does the floating and traveling takes place after what dewatering. Okay, so it helps you to achieve a smooth finish surface. Trimix skin is the functionality is very much similar to vacuum pump. Okay, in this case, you can see the red color thing. Okay, it is a mat-like structure with a particular cross-sectional area. Okay, so it is spread over the floor. So it will be able to suck out or excuse the excess water present in the concrete. It functions same as the vacuum pump. Fourth instrument that we are using is double beam screened vibrator. So you can see this is a beam-like structure. Okay, in beam we have the vibrator placed at the regular interval. So what does this vibrator do? It helps the concrete to get compact and leveled easily. Okay, so these are the instruments used. Next we'll see how the process is taking place. Okay, I think it's clear now what is vacuum dewater flow and what created a need for vacuum dewater flow and what are the instruments that are used. And now we'll see what is the process, how it is done. Okay. So the first thing is you prepare your sub base. Okay, you clean the surface. You remove all the unwanted particles present in your floor level. Okay, so then you divide the entire floor level into panel. So you don't cast the entire floor level in one go. Okay, we cast panel by panel. Okay, after that we prepare the framework using our steel channel, and we lay down the steel bar. That is nothing but your reinforcement. After placing the reinforcement, we mix the concrete, and we try to place the concrete and compact it so that it removes the air voids, and the vacuum dewatering process starts. Okay, the vacuum dewatering removes your excess water present in the concrete. Okay, so you can see this process starts immediately after the vibration. Okay, first initially what we place, the filter pads are placed on the freshly prepared, that is fresh concrete. So it leaves a gap of 4 inches. Okay, 4 inches on all the side. Okay, trimix suction skins are used here. Okay, the top cover is then placed on the filter pad and rolled till it covers the exposed concrete on the all side. Okay, and the top cover is connected to the vacuum pump, and the vacuum pump sucks the excess water. Okay, so we maintain the process lowers water content up to 15 to 25%. This process takes place approximately 1.5 to 2 minutes per centimeter thickness of your flooring level. Okay, after this dewatering process is done, the surface is troubled. Okay, so you can see that the dewater concrete is compact and dry in such that even if it is possible to walk, even if you walk on the floor, it doesn't make or any leave the footprint. So that makes the concrete floor ready. That is, we made a perfect concrete floor. Okay. So you can see in the first picture, that is, filter pads are laid. Okay, so it gives 4 inches gap on the all the 4 sides. Okay, the filter pads are placed so that there is no sealing edge around it. Okay, then over that we roll the top cover to unroll the filter pads. Next, we fit the suction pipe hose to the top cover, and this hose is connected to the vacuum pump. The last picture is the surface has been already vacuumed, so you can see a person earlier. He uses a floater machine to travel the finish to get the finished surface. So you can see this slide shows you about the various 4 stages. Okay. The first, from here the work starts. Other person is power traveling, float traveling. We have beam here. Okay, this main section part is getting vacuum dewatering. That blue color stands for the suction, skin suction. So what would be the advantage of vacuum dewater flow? One, it results in reduction of water cement ratio. So if the reduction of water cement ratio leads to your early setting and high strength ratio. Okay. So it helps to achieve a compressive strength. As I said, it helps in increasing the compressive strength. So it up to 40 to 70% is increased. And the surface hardness is also increased by 130%, and water absorption is reduced enormously. It is some additional advantages also given. It gives you minimum dust, level floor accuracy, minimum crack formation, improved wear resistance, elimination and minimization of overtime, and high and early strength floor. Okay, we have void and denser concrete is also achieved. So where the vacuum dewater flow is applied, it is mainly used in warehouse, road, cellular or parking areas, production areas, industrial shop areas, and base floor for using a epoxy, PU mats, and wooden floors. So in general, in putting in a nutshell of what is vacuum dewater floor is nothing but a concrete floor is maintained as a process or a construction of concrete floor by the removal of excess water from concrete with the help of vacuum. Okay. Now I'll show you a video on how that vacuum dewater flow takes place. Okay, so you can see this a filter mat. Okay, why the presence of filter mat is provided? So the cement particle does not get escaped through the suction. Okay, since cement is very finer particle, it can get clogged in your suction hose. Okay, so you can see a suction hose pipe is here. You try to roll the top cover. Okay, we are moving forward. This portion is nothing but your beam vibrator. Okay, you can see a rectangular member. It's a beam vibrator. So this is the vacuum pump is getting started. You can see a blue pipe, that is a blue hose is being connected to your filter pad. So you can see the water has been getting collected here. So this is your beam vibrator. So dewatering process takes approximately 1.5 to 2 minutes per centimeter thickness of your slab. So the process is very fast when compared to other manual concrete flooring. So after dewatering, the floater machine is used to trowel it. So, okay, the troweling is nothing but the finishing of concrete. So you can see the personnel here. Okay, the work personnel is able to stand and work over the concrete floor without making any footprint. He doesn't leave any footprint, so that it says that the concrete floor is ready for finishing. So we have removed enough water to achieve strength from the concrete. So by standing only, the personnel is able to do the troweling process. Okay, so he finished the surface very smoothly. Okay, is that clear? And this video gives you a more elaborate idea about vacuum dewatering flow process. And thank you.